Now, I can further show using some physical arguments, which I am not going to present explicitly here, that this rank 2 tensor in the case of these media is actually symmetric. So, chi 1 2 and 2 1 are equal, chi 3 1 and 1 3 are equal, chi 3 2 and 2 3 are equal. Okay. We can have there is a robust argument for explicitly showing this, that is one fact. Okay. The second aspect that goes along with this is, which I am not again going to prove to you, but you may have already studied this as part of a math physics or an engineering math course, that is, I have to take out some part of my screen for writing. So, let me do that here. I can always find a coordinate system so that chi I j is diagonal in this system. So, that system for a given medium is called the principal axis system. So, that for any medium, for its complete description as far as linear light matter interaction is concerned and the relationship between P and E is concerned, I only need to know and therefore measure or determine 3 numbers, chi 1, chi 2, chi 3, where chi 1 is chi 1 1, chi 2 is chi 2 2, chi 3 is chi 3 3 in the principal axis system. This lends itself to the idea, okay, that I can now visualize these 3 numbers in this coordinate system x 1, x 2, x 2, x 3 to be forming something like an ellipsoid, where the intercept of the ellipsoid is related to chi 1, chi 2, chi 2, chi 3. Okay. In other words, what I am, will try my best to sketch this right. say x, y, z. If I choose my axes such that x, y, z are the principal axes, o x, o y, o z are the principal axes, then the intercepts that the ellipsoid makes on the x, y and z axes will have something to do with the values for chi x or chi 1, chi 2, chi 3. Now, if I am forced to use a different coordinate system because of real life considerations, a crystal whose principal axis I do not know or whatever like that, or any other scenario you can think of, then all you got to do is to do the following. You need to know these 3 numbers and the relative orientations of that coordinate system with respect to this, and you can get all the 9 chi's, values for chi, of which only 6 are independent in general. Okay. Furthermore, a medium in which chi 1 1, chi 2 2, chi 3 3 are all different is called a biaxial medium, whereas a medium in which chi 1 not equal to chi 2 not equal to chi 3, but if we have chi 1 equal to chi 2 but not equal to chi 3, then you have a uniaxial medium. So, in the next lecture I will bring you a crystal that is uniaxial, but I will request one of my friends to remind us about it. We will see a little bit about it very soon. So, what is the purport of all this stuff? Chi mediates the interaction between E and P, P being the polarization. As a consequence, chi also mediates E and D. P or D is a matter of choice for us to use. D is epsilon naught E plus P. So, we will see that they are both going to be interrelated. In the case of linear media, where we are now discussing just the first term of this equation, we have so far discussed only the first term of this equation. I am not going to dwell on the other terms chi 2, chi 3, chi 2 of I j k and chi 3 of I j k l. I am not going to get there for the moment. I have just Taylor expanded it and respected the fact that E is a vector. So, the second order E square term I have written it as E j E k, E cube term is E j E k E l. Apologies for the fact that the subscripts got messed up in my rendering here. I will fix this the next time. So, this is E j E k, this is E j E k E l. All right. So, but I have not considered these parts yet. We have not, or I meaning we did not. But this is a good place to be in, because now if I consider a medium without free sources of charge or current, okay, as well as a medium which is not magnetic, a medium which is not magnetic, M can be set to 0. So, B is just mu naught H, mu naught is a fundamental constant, okay, the permittivity of free space. Then we can easily write Maxwell's equations down now, so that we have div E is 0, div B is also 0, okay, and curl E is minus dB by dt. The only equation that undergoes any significant change is curl B is, which anyway was curl H earlier, is mu naught epsilon naught d dt plus mu naught dP by dt, where P is the new actor in this episode. P is now popping its head up. Of course, that is the only place left for matter to show its face, because everywhere else either di V or di B is 0, and in the other case only E and B are related, there is no space, and the medium we said is non-magnetic. E is the pristine field you apply on from either ends of a capacitor. So, you can't touch E, it is just what you control to apply. Matter can only act through this one term in this entire set of 4 equations. Okay, but you can probably see the wave equation through this by taking the curl of B equation once again, or curl of E equation, whichever way you look at it, and we would have propagative phenomena emerging out of that, right. So, let us do that. We rederive wave equation, but this time without disregarding the polarization field. Polarization field is non-zero, this is a wave. We want to describe the scenario where a wave is propagating through matter. Okay. And this medium has a certain chi of the first order, and the wave is incident, and something happens to it inside matter. Right, this is the scenario we want to describe. I have no basis, I had no basis for it until now, especially even for the case of linear interaction, but now we do, because we now can deduce the wave equation for the electromagnetic wave inside matter. We have a golden chance to do that. So, let us exploit it. Take the curl of E equation, on both sides do the curling. So, here you have curl of minus dB by dt, but the operators can be swapped, but curl B is nothing but mu naught epsilon naught d dt of E vector, or the vector field E, minus, or rather plus mu naught d dt, or the time derivative of the vector P, the polarization field. Okay. Substitute for that in the equation here, and we use the fact that divergence of E was 0. Okay, we have used that in jumping to this equation. You can do this well, you have already deduced the wave equation. If I now consider a 1D case, okay, which if you recall, when we studied waves for the first time, we looked at the 1D equation, which is kind of good enough for a lot of circumstances. Then we have, instead of the Laplacian being d2x by d2 plus d2y by dy, d2x by d2e by dx2 plus d2e by dy2 plus d2e by dz2. So, we do not have x or y in the 1D, we choose z to be our spatial coordinate of interest and significance. So, we have d2e by dz2 minus 1 over, we use c square, but we are going to put a naught to designate the fact that this is the in vacuo speed of light, which is where c naught is 1 over the square root of mu naught epsilon naught. Okay. So, 1 over c naught square d2e by dt2 plus mu naught d2 p by dt2, second derivative of the polarization field with respect to time. Okay. Now, here comes the major leap. Although we said that we Taylor expanded P in terms of E, which we did, right. We Taylor expanded P in terms of E. Hitherto we said P is, or Pi is epsilon naught chi I j E j plus E square term plus the E cube term plus higher order terms. Right now we are keeping things linear, so we do not worry about these at the moment, but we soon will, right. But let us keep them in general. Even for linear interaction we said all this, okay. But where does chi I j come from? Where is the origin? Now, I told you that P is essentially dipole moment per unit volume, correct? Correct. But what is dipole moment? Dipole moment is nothing but the charge multiplied by the separation between the two charge centers. So, dipole moment is E times. So, let us call the individual dipole moment to be, if dipole moment is little p, not capital P, I hope I have sufficiently distinguished it, then I have P where V is volume, dP by dV, which can depend on space and time, correct, dipole moment per unit volume. But little p is E times, okay, I should not write it like chi. So, let me write the x sub E carefully, alright. If now the number of dipoles per unit volume is n, per unit volume is n, then P is nothing but, capital P is nothing but this n multiplied by E x e, and the time dependence comes from the time dependence of x e. The number of dipoles is going to remain constant if I think, I mean any medium, okay, in a closed system. We have to make such assumptions because we are not like removing stuff and adding stuff and so on and so forth. Okay, if you ionize a gas, you have a leaks through something, your medium is a plasma, then n can also change, maybe n even changes with time, but we are not considering those exotic phenomena at the moment. We stick to conventional realistic media. Then plug in this stuff inside, plug in for E, we know, we deduce the fact that of plug in x c, rather plug in for x c, x c has all its nice frequency dependence multiplied by E of t. So, that is the linear part. Here x c depends linearly on the electric field E, alright. So, plug this into the equation. P is N E multiplying x of t, correct, N E multiplying x of t. Now, what does this equation tell us? This wave equation, what is it talking to us? It is talking to us. This wave equation is talking to us, all right. What is it saying? If this was the homogeneous equation where the left hand side was just this and equal to 0 on the right, we did not have this term for P. So, maybe there was, this did not exist on the right hand side, it was 0. Then it is just a free propagating wave, a wave, the electromagnetic wave propagating in vacuum, ideal vacuum. Okay. But now, so the wave exists, but what is on the right hand side? The thing on the right hand side is now behaving like a source. Right? It is behaving like a source. For example, think of Gauss law. Divergence of D is rho free. We said divergence of E is rho free by epsilon naught, if this was in vacuum, the medium of interest was vacuum. So, we know that this is equivalent to, for a point charge, the field of a point charge as described through Coulomb's law, which is the field is the force produced by this test charge on a unit charge placed anywhere is the field. So, this is the equivalent expression of Coulomb's law in a differential equation. So, what is this? This is the field, consequent field, if you wish, and this is the source. Here the free charge is a point charge, is a charge density of some kind with a net non-zero value. But you can also, we could also have considered a dipole, which is net zero charge, it is just displaced, two charges displaced, they are somehow held together, and the dipole also can have field lines, right. Isn't the dipole field like that? The dipole moment and the field vectors are opposite. Okay, so this is the scenario of a dipole. So you can always have fields and their consequent sources. So look at the left hand side of this equation, fields, but in this case a propagating field. Here source. What is the source? If P were to be stationary in time, dP by dt is 0, then no propagating wave can emerge out of that. If P oscillates in time, changes in time, then a propagating wave could emerge out of it. Where is the oscillation of P coming from? The oscillation of P in time is coming from the oscillation of the charge cloud about the atomic nucleus, the dipolar oscillations there. So, dipolar oscillations of the charge cloud, okay, I have an animation over there, so I am trying to trigger that guy in. The dipolar oscillations of the charge cloud gives rise to an oscillating P, the oscillating P is the source of the wave, right. So that is where matter is giving back to the wave which kicked it into oscillation. It is a counter punch, okay, and they are a pair of friendly boxers in a ring, okay. So that is the source term. So on the right hand side we have a source term. So now the nice relation, we stick back the frequency dependence of E, okay, of xc rather, the frequency dependence of xc, put this back into the expression connecting E and P, and here you have the complete description of the polarization from an atomistic perspective. We do not need to look any further. If you did not know that the nucleus is made up of quarks, would not have mattered for us here to know this, or the proton is made of quarks. You need not have known the substructure of the constituents of the nucleus. All you needed to know is the interaction, or how to describe this Xc, right. But Xc is entirely determined by gamma and omega naught, gamma and omega naught. Okay, so I need to determine these two quantities, gamma and omega naught. Actually, gamma and omega naught are not entirely dependent.